Okay, in this problem, we are given some initial concentration values, and we need to predict which way the reaction is going to move, whether it's going to move and create more products, or if it's going to the right, or if it's going to move to the left and produce more reactants. So if Kc, again, which is our KEQ, equals 0.064 for this reaction, and given that the concentration of H2 equals 0.45 molar and the concentration of water equals 0.37 molar, which way will the reaction proceed? So when we're given an equation like this, which gives us our Kc or KEQ value and asks us which way the reaction will proceed, we know that we need to do a comparison between our KEQ and our reaction quotient Q. So to set up Q, we're actually going to set up Q the same way that we set up K, which is our concentration of our reactants, our concentration of our products over our concentration of our reactants. So Q equals the concentration of our products over the concentration of our reactants. The only difference is that when we're dealing with KEQ, it's going to be the concentration of our products at equilibrium and our reactants at equilibrium, and when we're using Q, it's going to be our concentrations of our products and reactants initially. So we're going to plug in the information that we've been given. So first we're going to set it up. So we're going to have our water, H2O, cubed times Fe squared divided by Fe2O3 times H2 cubed. But what I notice is that I have a solid in my Fe and a solid over here, so I can actually omit both of those from my equation. So I'm left with H2O cubed divided by H2 cubed. Now I can plug in my values, and for H2O I get 0.37 cubed divided by my H2, which is 0.45 cubed. And if I do that math, and I do it correctly, I'm going to get 0.56 for my Q value. Now to figure out which way that this reaction is going to proceed, I need to compare my Q to my K. And I always need to put my Q on the left. So 0.56, and that's my Q value. And my K value is equal to 0.064, and that's my K. And remember, your Q needs to go on the left. That's important. If you put your K on the left, it will mess you up and you'll actually get an incorrect answer. So 0.56 is clearly the bigger one. So we're going to do our little greater than symbol, and we can turn our greater than symbol into some sort of alligator or shark, whatever you want to turn it into. Those are supposed to be teeth. And our alligator is going to be chomping towards the left. So this reaction is going to shift towards the left. So we're always going to follow the way the alligator is chomping. If we calculated our Q value and it turned out to be equal to our K value, then our system is at equilibrium. If we calculated a Q and it turned out that Q was actually smaller than K, our reaction would proceed to the right, because that's the way our little monster would be chomping. And that's how you can determine which way a reaction is going to proceed given the equilibrium constant and then finding the reaction quotient.